All right, so today we're going to look at the remainder/factor theorem. And so this theorem can be used instead of division when your goal is only to find the remainder and not the quotient itself. So if you're just wanting to know what the remainder is, or if you're just trying to figure out if a particular polynomial is a factor of another polynomial, you can use the remainder/factor theorem. You can determine what a remainder is without having to divide, and you can also use this to determine if something is a factor of something else. So here's the definition of the remainder theorem. It says if polynomial f of x is divided by x minus c, then the remainder is f of c. So that might be a little confusing. So I'm going to step through that with you on these examples, and it should be, maybe this will make more sense. So when I plug in c for what this means is my x, well, how I get that c value is I'm taking my x minus c and setting it equal to 0 and solving for x. So it adds c to both sides. That's why I am getting a c here instead of a negative c. So what we're going to do here is we're going to take our factor here, x minus 1, and we want to know what the remainder is when I divide it into this particular polynomial. I could do this synthetic division, but this is a quicker method. So all I do is I set this equal to 0 and solve for x. So I'd add 1 to both sides, so x equals 1. So what I'm going to do is I'm going to plug this 1 in for x in this function. So 1 to the 5th power minus 2 times 1 squared plus 5 times 1 plus 2. And whatever this function value is, whatever I get here, that will be my remainder. So we'll go to our graphing calculator, and it's very important that you use parentheses. So 1 to the 5th power minus 2 times 1 squared plus 5 times 1 plus 2. And I get 6. That means the remainder is 6. That means if I divide this polynomial by this polynomial, I would get a remainder of 6. So let's take a look at this next one. I want to figure out what the remainder would be when I divide x plus 2 into 3x cubed minus 4x squared plus 6x minus 1. So again, I have to take my x plus 2 and set it equal to 0 and solve for x. So I'd have to subtract 2 from both sides. 0 minus 2 is negative 2. So I'm going to replace my x with negative 2 in this function. Going to my calculator, 3 times negative 2 to the 3rd power minus 4 times negative 2 squared plus 6 times negative 2 minus 1. I'm just going to make sure I've got that written correctly or typed in correctly. 3 times negative 2 cubed minus 4 times negative 2 squared plus 6 times negative 2 minus 1 equals. So f of negative 2 equals negative 53. So what that means is that my remainder is negative 53. So if I took x plus 2 and divided it into this polynomial, my remainder would be negative 53. So what a remainder means, if I get a remainder when I divide something into another, one factor into another polynomial, or one polynomial into another polynomial, what that means is if I get a remainder of anything other than 0, then that means that this would not be a factor of this polynomial. This would not be a factor of this polynomial. If I get a remainder of 0, then that means it goes in evenly, and then that would be a factor. So that's what this factor theorem says. If I get a remainder of 0, this this was a factor of my original function. So down here it says, show that x minus 3 is a factor of this polynomial. So I'm going to set this equal to 0 and solve for x. So x equals 3. I'm just going to show that when I plug 3 in for x here, I'm going to get a remainder of 0. So this is just like a little proof. They're telling me that it's a factor. I'm just proving it. And how I prove that is I show that that remainder is 0. So back to my calculator. 3 cubed minus 4 times 3 squared. Whoops. Oh, it's one of those days. 3 cubed minus 4 times 3 squared plus 2 times 3 plus 3. And you can see I get a 0 here, so my remainder is 0. So that proves that it's a factor. All right, so I'm going to show that this x plus 3 is a factor of this polynomial 15x cubed minus x squared minus 114x plus 72. So again, I take my factor and set it to 0. So I get x equals negative 3. I prove that by replacing all my x's with negative 3 and show that I get a remainder of 0. Again, parentheses are very important. So here's my graphing calculator. So 15 times negative 3 to the third power minus parentheses negative 3 squared minus 114 times negative 3 plus 72. And you see again, I get a remainder of 0. So there's my proof that x plus 3 is a factor of 15x cubed minus x squared minus 114x plus 72.